Okay, so here we go. We are beginning our exciting journey through Chapter 2. Chapter 1 was kind of a nice, gentle introduction into kind of a big picture look at statistics. We're going to kind of start moving it down to a somewhat more microscopic level now as we segue into Chapter 2. So, in statistics, really in terms of any research, we always want to test any question of interest with appropriately gathered and topically relevant data. So after spending a fair bit of time in Chapter 1 discussing how it is that we actually go out and gather information, right? How do we gather data? What we're going to start working on now, we're going to talk about, it's going to be really the main idea of Chapter 2, is what do we do with this information once it's been gathered? So for example, imagine you're the course coordinator of Math 121. Well, for the fall and the spring semesters, all Math 121 students are all forced to take the same common final exam. So here I say 1,200 students, but to be honest, I think the number of students taking it every semester is more in the 2,000, 3,000 student range. So imagine you're the course coordinator. You need to, at the end of the semester, tell, say, your department chair how well students did in Math 121. Now, would you take the 1,200, the 2,000, the 3,000 individual scores, the scores of all the students on the exams, which would be what? Which would just be a bunch of numbers on ream after ream after ream of paper, just boom, thumped on the desk of your department chair? Of course not. What would you do, and what is it that we're learning to do in Chapter 2? Exactly. We would take those 1,200 numbers, we would take all that information, and we would in some way summarize that. Now, the question is, how do we summarize that? And as we'll learn as we work through Chapter 2, and probably a lot of us already have a bit of an intuitive answer to this already, we can summarize this in a lot of ways. We could, for instance, say how many students got A's, how many students got B's, how many students got C's. We could say what percent of all students got A's, what percent of all students got B's, what percent of all students got C's. We could talk about the average score on the exam. Maybe the average score was something like 24.2 out of 33, right? There's a number of different ways that we can summarize that. Each of these different ways of summarizing has their own pros and cons, and this is going to be what we talk about in Chapter 2. Chapter 2 is called Descriptive Statistics. It's essentially all the different ways that we could take the large amounts of information that we talked about gathering in Chapter 1, and we could in some way sort of summarize them, kind of take this huge lump of indigestible numbers, and in some way try to coax forth the picture or message that it's trying to communicate to us. Now, the first way that we're going to look at summarizing data is we're going to look at ways to graphically or visually summarize data, right? Sort of based on that idea, we've heard that motto or that maxim many times, right? A picture speaks 1,000 words. So, the two main ways of graphically summarizing variables, if you're focusing on a qualitative variable, remember we talked about qualitative variables in Chapter 1. A qualitative variable is something that's sort of non-numeric. The graphical ways to summarize a non-numeric variable, the most popular ones are pie charts and bar graphs. A pie chart, really both of these charts are things that I'm sure you've seen dozens, if not hundreds of times in things like Time Magazine, Sports Illustrated Magazine, Cosmo, right? These are very widely used ways of depicting information when the variable of interest is qualitative. So a pie chart, the way it essentially works, it takes each category, right? These qualitative variables have categories, and each category is represented as a slice of pie. Pie charts are nice because they show not only how large each category is, but graphically, sort of visually, they let us see how large it is relative to the whole. Now, a drawback is that they are only useful in situations where the values of each category are percentages that add up to 100. You might say, well, what situation doesn't fall under that? And we'll talk about that in a few slides. So, I don't know, I pulled some examples off the internet, some ones that made me somewhat chuckle. And so here's a pie chart. The different categories are 4 different things that you might say when you stub your toe. You might go, dollar sign, pound sign, exclamation point, percent sign. It's one thing that you might say. You might say, and sign, asterisk, and sign, caret. That yellow one, I don't even want to say that word. It makes me uncomfortable. Or, right, we might say, ouch. Now, it turns out, right, they say this is sort of the percent of times that each one is said. It actually looks like what? That the green, the blue, and the yellow are all kind of roughly a third of the circle. And there's that small little sliver, a small percentage of people, right, say, ouch. Most of them are using some censored curse word. So what I meant when I said that we get a sense of how big each is relative to the whole, right? When I look at those 3 main categories, I could tell that each of those is probably roughly a third, right? So roughly a third of all people use each of these different curse words. Here's another example of a pie chart. So this one takes a fictitious class. As we can see, the class has, 28 students in it. And we break them down into these different categories. So, right, the green slice of pie is the A students. The purple slice is the B students. The red slice is the C. The blue slice is the D. And so, thankfully, no students, it appears, got Fs on this particular class or on this particular test. Now, this one's a little more descriptive than the other pie chart because not only do we have the slices, but next to it we have the number of students as well as the percent of students that fall into that particular category. So, what can we see? We can see, for instance, that probably the most common grades are B's and C's. We can see that B is a little bit more common than C. Now again, we're going to contrast this soon and compare this to really the same information summarized in a bar graph. We can easily see that the most common grade is a B, but even more than that, we can see that that particular category, we can see this very quickly, very easily. That's the power of the visual summary, is how instantaneously that information is communicated to us. The human eye is very good at looking at pictures and understanding what those pictures mean or what those pictures are telling us. We can see that the percent of students that got a B is a bit less, but close to half of the class. Pie charts are easily made in Microsoft Word or Excel. I could spend a few slides teaching you how to do it, but to be completely honest, you could just as easily learn how to do it by Googling pie charts Microsoft Word or pie charts Microsoft Excel or whatever other program you might be working in. And you get a very nice and easy step-by-step tutorial on how to put together your own tasty pie chart. Now, the second way of summarizing information is something called a bar graph. A bar graph represents each category not as a pie, that's what we just learned how to do, but instead as a bar. Now, it's important. It's important to make sure that each bar does not touch. We do this to emphasize the non-numerical, the discrete nature of the variables that we're looking at. It's also extremely important to make sure that each bar has equal width. Failing to do this can make the graph visually deceptive, right? As we see when we look at a bar graph, we're really using the heights of the bar to tell us which category is sort of more represented than another. However, it's been shown that the human eye does not compare heights. The human eye compares area. Now, if every bar has an equal width, then comparing height and comparing area are essentially the same comparisons. But if you make different bars have different widths, you're going to make a deceptive, somewhat distorted graph. I think our textbook might talk about this a little bit, about how once you have a bar graph, you can make it aesthetically pleasing to order or arrange the bars, maybe starting from the largest, most represented category to the smallest, or perhaps the smallest to the largest. To be truthful, I don't know that I see this done very often in practice, but it is certainly something that could be done. And so here we are, back to our student grade. So this is the exact same information we saw before. So we can sort of compare a secondary way of representing the same information. So we have 4 categories, A, B, C, D. We can again see that the purple bar, the B's, and the red bar, the C's, are the largest bars. Hence, those are the grades sort of most commonly received in the class. Perhaps a little easier than we were able to do it in the pie chart, we can see that the B's outnumber the C's. When we were looking at the pie chart, it perhaps wasn't quite as easy to see that. Now, what we can't necessarily see as easily that we could see in the pie chart is what we said about the B's being a little less but close to 50% of the class. Because the bars are sort of pulled apart and stacked next to each other, you lose that sense of a category relative to the whole, right? The slice and how much area it takes of the whole pie. In a pie chart, as I said, you can see the percentage of the whole easier. In a bar graph, it's harder to see that. We can see that B's are the most common grades, but it's not obvious without really thinking through and counting up the numbers and doing the math. It's not obvious that the B's are a little less but close to 50%, whereas that was much easier to see with the pie chart. Pros and cons. Here's another bar graph that I found. It's a slightly more graphically clever one. It's the top 10 most read books in the world. I think it's kind of an interesting graph. I like books and I like reading, so I think the information content is interesting. The Holy Bible, I think I would have guessed. The other ones, I don't know that I would have guessed. The quotations from Mao, from Chairman Mao, makes sense. I don't know that I would have guessed that, but it makes sense to me. I'm actually maybe a little surprised maybe that one's not closer to the Bible. Then you got some neat ones. Harry Potter's up there. Lord of the Rings is up there. A couple books that I haven't heard of, such as Think and Grow Rich, apparently is one of the top 10 most read books in the world. Just between you and me, I don't want to seem uncouth and illiterate, but I've never even heard of that book. I might have to Google it or check it out on Amazon.com after I finish narrating this. So right here, they kind of cleverly made the bars out of books. So you can do lots of neat things to kind of dress up your graph, make it a little bit more visually appealing or visually interesting. Now, I actually think this is an interesting example because of the scale of this graph. So I think the units are in millions. If you kind of squint to the left-hand side, you can see it's numbers of millions of copies sold in the last 50 years. So 3,900 million Bibles have been sold. And so that really kills all the others. The 10th most read is 27 million. So that's a huge difference between the most read book, 3,900 million, and the 10th most read book, which is 27 million, The Diary of Dear Old Anne Frank. Now, as often happens in situations where one category really dominates the others, it can kind of screw the scale of our graph up and make it actually a little bit difficult to use. Right, so let's compare, for instance, the Da Vinci Code to the Diary of Anne Frank. The Da Vinci Code is 57 million. The Diary of Anne Frank is 27 million. Right? 27 million it's what? It's really very close to half of 57 million, right? However, right, to our eye, those bars appear to have pretty much the same height. We'd be tempted to look at the Da Vinci Code and the Diary of Anne Frank and say, oh yeah, it looks like they're really close to this sort of same number of ordered books or the same number of read books. But that's definitely not the case, right? In fact, the Diary of Anne Frank has sold half of what the Da Vinci Code has sold. Why is that scale sort of so messed up? Well, it's really a couple things. One, it's that dominance of the Bible, but two, look where 0 is, right? 0 is actually right at the very, very top of the book. So most of those books actually are not supposed to be counted as a number, right? It's only that top little smidge of the book that's counting. And so, right, the amount of book over that 0 line for Da Vinci Code is twice the amount over the Diary of Anne Frank. It's very difficult for our eyes to see that or process that, wouldn't you agree? So I kind of pulled this example out to show a few things. One, an interesting example. Two, how we can make these things kind of graphically more fun and interesting. But three, also the danger of doing it and things that we want to keep in mind. One, when we're interpreting these graphs, to be sort of careful in terms of how we interpret them. And two, right, to perhaps be careful if we were to put any of our own together, say sometime down the road. Alright, one last example to conclude with, sort of tying together the discussion of bar graphs versus pie charts. So let's say that we have the following genres or following categories of music. We have hip-hop, we have country, we have modern contemporary, we have death metal, and of course we have nerdcore hip-hop. So let's say that we conduct an interview of 200 Westchester students. We're maybe going to do an article in the Quad, and we ask them to place a check mark next to each category of music they enjoy. Now, we're not asking them to pick their favorite. We're just saying, of these different genres of music, of these 1, 2, 3, 4, 5 genres, which of them, might be all 5, could be none, do you actually enjoy listening to? So which graphs do you think are appropriate for summarizing these results? I'm going to drink a little bit of water. I have no idea what kind of sound it's going to make while you think about this, so I'll give you a second. Exactly. The appropriate graph is the bar graph, but not the pie chart. Do we see that? It's another weakness of the pie chart. Remember, the pie chart's only appropriate when the percents of the categories are forced to add up to 100%. That's not the case here, agreed? I'm not saying that it's likely, but it certainly could happen. That 80% of students check hip-hop, 80% check country, 80% check modern contemporary, 80% check death metal, and 80% check nerdcore, right? Our percents don't add up to 100. They don't have to, basically because students can check more than one music genre. And so because of this, if you imagine trying to put together or assemble your pie, well, you would put 80% of the pie for hip-hop, and then you would try to do the next 80% for country, but of course you've run out of pie, and you haven't even done the last 3 categories. Now, you could very easily do a bar for hip-hop, which has a height of 80%, a bar for country, which has a height of 80%, a bar for modern contemporary that has a height of 80%, and so on, right? The bar graph has a little bit more flexibility than the pie chart does. Alright, hopefully that makes sense. Congratulations on getting through another sliver, another fragment of these narrated PowerPoints.